Now the directions have changed here a teeny bit, but it's still the same process. This time it says solve the equation rather than find the zeros. It's still the same thing. We need to make a list of our possible rational zeros, which the factors of 15 are 1, 3, 5, and 15, plus or minus of all of those. So that's 8 possibilities. So I always start with 1. Let's check it out. 1 times 1 is 1. Add and get 4. 1 times 4 is 4. It gives me negative 9. 1 times negative 9. And you can quit there. You don't actually have to go down and write negative 24. All you're looking for is that does not give me 0, so 1 doesn't work. Next thing to try in order will be negative 1. Negative 1 times 1 is negative 1, gives you 2. Negative 1 times 2, add gives us negative 15. Negative 1 times negative 15 is a positive 15, which is my 0. And let me say again, I know how many of these I'm going to have to do to divide because I've already done the problem. You don't know. So it's not a matter of you just get to write down 2 and that's all you do. You might have to do as many as 8 of these to find one that works. But we found one that works. So let's fill in our variables. So this is x squared plus 2x minus 15 equals 0. We lucked out on this one. This one does factor. Since that's a negative, one of these is plus, one's minus, and it's going to be a positive 5 and a negative 3. Set each one equal to 0, and do you have to write down the setting equal to 0? Probably not. At this point you realize if it says x plus a number, that your root will be negative, and if it says x minus a number, your root will be a positive. So our 3 zeros, or our 3 roots, are negative 1, negative 5, and 3. Now notice, all of these are rational numbers. I could have done my division in a different order, and maybe I would have tried 3 first, and then I would have gotten a different equation right here, but it would have factored and given me these two. It doesn't matter what number you initially find to work. It's just a matter of find something to work. If it's x cubed, you just have to find one rational root to work, and then you're on your way. We'll see later on in another video if it's x to the 4th. We will also look at if there's a coefficient in front of x cubed. The only reason we're allowed to just look at the back numbers is because the coefficient here is 1. The next video will address the fact of that being a number other than 1. Here's another one where the lead coefficient is 1. So to name the possible rational zeros, all I have to look at is the constant term, which is going to be 1, 2, 3, 6 as my possible rational zeros, plus or minus of all of those. One thing to point out on this one, notice we went from x cubed all the way down to x, so that when I set up my synthetic, I need to have a placeholder. Be sure you're aware of that because you're going to need the placeholders on some of these problems. So I'll start with 1, bring down my 1, draw my line, and start my synthetic. 1 times 1 is 1, add to get 1, 1 times 1 is 1, gives me negative 6. 1 times negative 6 is negative 6, add and get 0. So right off the bat, we found one that worked. Fill in your variables. This is x squared plus 1x minus 6. Set that equal to 0. And this factors as x plus 3 times x minus 2 equals 0. Set each of those equal to 0, which is just going to turn this into negative 3. Turn this one into positive 2. Together with this 1 that we found initially, and there are our 3 zeros. Now, to find the zeros of a function that has a coefficient that is not 1, your possible rational zeros are not just relying on the last number. You have to make a fraction of the factors of the constant, meaning the factors of the back number. And of course, this is assuming that your polynomial is in descending order of exponents, over the factors of the lead coefficient. So I just think about this as being the factors of the back over the factors of the front. So the factors of 2 are 1 and 2. The factors of 15 are 1, 3, 5, and 15. So our possible rational roots will be plus or minus. Now, just look at the 1. Ignore the 2 for a second. I'll just scribble it out. Put 1 over each of these numbers in the denominator. So that's 1 over 1, 1 over 3, 1 over 5, 1 over 15. So we're done with the 1. Now let's scribble out the 1 and just look at the 2. We need to put that 2 over each of these numbers in the denominator, which will be 2 over 1, 2 over 3, 2 over 5, 2 over 15. Now we need to try each of these. This is a pain because look how many there are. There's 8 of these things I've listed, but plus or minus makes 16 possibilities. So we just got to try. If I try 1, let's bring down our 15. 1 times 15 is 15, gives me 29. 1 times 29, add to get 26. 1 times 26, no way does that give me 0, forget 1. Let's try negative 1. Negative 1 times 15 is negative 15, which gives me negative 1. Negative 1 times negative 1 is positive 1, which will give me negative 2. Negative 1 times negative 2 is positive 2, which gives me 0. So even though there were a whole lot of potential problems, we found the root that worked pretty quickly. Now, I don't have room to squeeze that in there. This is going to stand for 15x squared minus x minus 2 equals 0. This is a quadratic. Our choice is to check to see if it factors, or you could go directly to the quadratic formula if you don't like to factor. This one does factor, though, pretty easily. To get 15x squared in the front, I would need 5x and 3x. The last sign is negative, so one of these is minus and one of these is plus. You know, I'm not sure which goes where to start with, so I just plop them down. I can always fix that if I need it. The only factors of 2 are 2 and 1. And if you check this, this is a negative 6x. Across here would be a positive 5x, which does give me negative x in the middle, so I did put my signs in the correct place. Set each of these equal to 0. So we have 5x minus 2 equal to 0, and we also have 3x plus 1 equal to 0. Two simple equations to solve. Add 2 to both sides, gives us 5x equals 2, divide by 5, and x is 2/5. Same process over here, subtract 1 from both sides, and then divide by 3, and x is negative 1/3. Notice 2/5 is one of the ones I would have eventually tried, and negative 1/3 is one of the ones I would have eventually tried. So our 3 zeros are negative 1, 2/5, and negative 1/3. So having this coefficient in the front changes two things for us. One is our possible rational zeros include fractions. The other thing it could potentially change for us, it just gives us more things we might have to try. Let's take a look at another one. Again, it's the factors of the constant term, which is the back, over the factors of the lead coefficient, which is the front. So my factors of the constant term are 1, 2, 4, 8, and the factors of the front are 1 and 3. Let's put this together as plus or minus. Put 1 over each of these. 1 over 1 is 1. 1 over 3 is a third. I'm finished with the 1. Put 2 over 1. Put 2 over 3. I'm finished with the 2. 4 over 1. 4 over 3. Finish with the 4. 8 over 1 is 8, and then 8 over 3. So here's all of my possible rational zeros, all of those plus or minus. Now just to save time, try on your own these synthetically, and you'll see that they just don't work. I'll go all the way to 2/3 because I do know this one works. 2/3 times 3 is 2. If you can't do this kind of fraction in your head, you can go over to the side and write it down. Or if you have a calculator that does fractions, just type it into your calculator. Negative 8 plus 2 is negative 6. 2/3 times negative 6 is negative 4. Negative 8 plus negative 4 is negative 12. 2/3 times negative 12 is negative 8, which gives me 0, and that checks. Fill in your variables. This is the polynomial 3x squared minus 6x minus 12 equals 0 that I need to solve. Let me go back and say this. You decide what order you do these in. You might want to do all of your integers first. You might want to do a couple of the integers and then go to the fractions. You might want to try these in the order in which you see them. It's all up to you, but just be systematic about things so that you don't leave out something that's important. Now I need to do this on the next screen. 3x squared minus 6x minus 12, the first thing I notice is that I can factor out a 3, which gives me this. Now when I think about factoring out a 3, I could divide both sides by 3 right now, because 0 divided by 3 is still 0. That makes that go away. This does not factor, so I've got to use the quadratic formula. Here's the quadratic formula. Here's my values for a, b, and c. Here's all the work for stuffing in my a, b, and c. You can check that on your own, and we end up with this. 4 plus 16 is 20. Do your factor tree on the square root of 20 gives you 2 times the square root of 5. Remember the triangle trick, and I can reduce 2. 2 goes into 2 once, 2 goes into 2 once, 2 goes into 2 once, which just gives me 1 plus or minus the square root of 5, along with the 2/3 that we found earlier using our synthetic division. So there's our 3 roots, or our 3 zeros of the equation.